lecture of the series, sponsored in part by the Same Nations Institute. I would like to take this time to acknowledge our generous benefactors who are sitting in the 4th row. Thank you so much for your commitment to addressing the concerns of our church and educating minds and hearts to change the world, the mission of USF. My name is Lauren Smith, and I'm a junior here at the University of San Francisco and a performing arts and social justice major. I've been practicing Catholicism for 8 years, and through youth groups, retreat work, theater, and activism, I remain a strong, committed Catholic in a rapidly changing church and world. The Lane Center shares in my mission. The Joan and Ralph Lane Center for Catholic Studies and Social Thought is devoted to research, education, and the promotion of Catholic intellectual heritage with a particular focus on the social teachings of the Catholic tradition. To assure you of our commitment to shedding knowledge on several controversial topics in the church, we have recruited some of the most qualified lay and clergy to hold these conversations throughout the semester. Maura Ryan joins us from the University of Notre Dame. Her primary interests are in the areas of bioethics and health policy, feminist ethics, and fundamental moral theology. She co-edited a book on global stewardship with Todd David Whitmore and published Ethics and Economics of Assisted Reproduction in 2001. Her articles have appeared in the Hastings Center Report, the Journal of Philosophy and Medicine, and Ethics and Behavior. She serves on the St. Joseph County Healthcare Advisory Consortium and the Ethics Committee for Hospice of St. Joseph County. Currently, she is working on the challenge of assisted suicide from feminist ethics. Assisted suicide from feminist ethics, because I got that in my notes. Without further ado, please welcome Maura Ryan to speak on Whose Holy Grail? Justice and Healthcare in the Age of Genetics.
Thank you very much, Lauren. One of the wonderful things about speaking at other universities is that you get a chance to meet such wonderful students and see the good work being done around the country. So it's exciting. One thing that Lauren didn't mention is that I am the mother of twin daughters who are just about 5 years old. And as you can see, I'm an older parent. So just one little story about being an older parent. My children are just at the age where they want to learn to read. So like diligent parents, we went around the house and we wrote out in big letters on strips the names of all objects. So television, stove, refrigerator, chair. And my 85-year-old mother-in-law came to visit, and she looked around the house and she patted me on the hand and she said, "I know, dear, I forget the names of ordinary objects too." So that is our house, where the AARP meets Sesame Street. And we're proud of it. As Lauren said, my topic today concerns how we distribute goods, healthcare goods, in a genetic age. I think that it's safe to say that we are in a genetic revolution. The success of the Human Genome Project, which was the 13-year effort funded by the Department of Energy and the National Institutes of Health to map and sequence the human genome, is rapidly changing everything, from the way we diagnose and treat disease, to the way we understand health and normality, to how we understand our relationships with other species. For religious traditions such as Christianity, which has spoken of the human person as the pinnacle of creation, genetic advances even raise deep theological questions as we discover how unremarkable we really are genetically. I mean, here as in everywhere, the devil is in the details, but if we consider it just numerically, we have about the same number of genes as a laboratory mouse and slightly more than a mustard seed. The Human Genome Project is really a stunning scientific achievement. Using samples from many donors, Scientists have been able to identify all the approximately 30,000 genes in human DNA and to determine the sequence of the 3 billion chemical base pairs that make up human DNA. According to the Department of Energy's primer on the Genome Project, the order of the base pairs spells out exact instructions needed to maintain and reproduce a living organism, whether it's a person, a tree, or a microbe. The Human Genome Project has been called the Code of Codes, the Book of Life, Science's Holy Grail. There are lots of applications for this information. We've all seen, for example, the use of genetic technologies now in the defense of innocence in the criminal court system. This kind of information can be used in industry. For example, we can determine, potentially anyway, we can determine particular susceptibilities to environmental toxins. But what I want to talk about today is application in medicine, specifically. Although progress from research to clinical application has been slow, and in many ways frustratingly slow, the long-range expectations for medicine coming out of the Human Genome Project are enormously exciting. In 2000, Francis Collins, who headed the Human Genome Project for the National Institutes of Health, predicted that within 10 years, we will have tests, and some performed even before birth, for identifying genetic predisposition to many of the major causes of death and chronic illness in this country: lung, colon, and prostate cancer, coronary artery disease, diabetes, osteoporosis. By 2020, doctors will rely on individual genetic variations in prescribing drugs and in choosing doses. Cancer doctors will use drugs that precisely target a tumor's molecular fingerprint. By 2030, he predicts that we will understand the genetic basis for aging, and clinical trials will be underway to extend human lifespans. An average lifespan of 90 is not unrealistic, and they're predicting well over 100. By 2040, gene therapy and gene-based drugs will be available for most diseases. Much has already been written on the ethical issues raised by the Human Genome Project. As part of the appropriations for the Human Genome Project, there were $395 million appropriated altogether, and of that, 3% was set aside from the outset for looking at what was called ELSI, the ethical, legal, and social implications. But not surprisingly, most of the attention within medical ethics, particularly in the United States, is focused on the issues of access and the control of information. Who has the right to genetic information? To what uses can it be put? What are the commercial boundaries on genetic material? What is the scope of our responsibility to future generations? What are the limits, if any, what we talked about this morning? What are the limits to a parent's freedom to alter or enhance an offspring's genetic makeup? These are very serious questions, and they deserve serious attention. Indeed, Lee Silver, who is a molecular biologist from Princeton, argues that the single most significant driving force in future applications of genetic technologies will be the desire of parents to provide their children with the best possible future prospects. But today, I want to focus on an area that I believe has received less attention, and that is, what are the implications of the genetic revolution for the multiple and unequal worlds of healthcare in which these technologies emerge?